Hi, Assalamualaikum. Today we're going to do the chapter on the powder, metallurgy and ceramic. So the content for this, we're going to look at the powder metallurgy process, the production of the metal powder, pressing and sintering, and then also we look at the powder injection molding and also process design consideration. So what is powder metallurgy? It's a metal and ceramic processing technology in which parts are produced from powders. And it can get into complex shape and sintered, in which heated without melting to form a solid piece. So they need to compact the metal powder or the ceramic, then they have to go through the sintering process. Usually for powder metallurgy sequence, they have the mixing, okay, and then they have pressing, and then followed by sintering. So the green compact, we call it for the powder metallurgy product in which not gone through the sintering process. So sintering is used to heat up, okay, for the particles to bond into hard and rigid mass. And it's done at the temperature below the melting point of the metal. And nowadays, powder metallurgy have become competitive compared to the casting, forging, and machining, and particularly for relatively complex part with a high strength and hard alloy. And commonly, this type of metal they use in which iron, copper, aluminium, tin, nickel, titanium, and also refractory metals. And for the powder ceramic, they have zirconium, aluminium, and magnetic oxide. Okay, why powder metallurgy is important? It can produce in mass, okay, to a near shape or near net shape, in which they don't have to do the machining or other process. And the waste are very little because the powder can be reused, and also it can be made into a specified level of porosity, especially to produce porous metal parts, for example, filter, oil impregnated bearings, gear, and sometimes a metal that are difficult to fabricate, they can opt for the powder metallurgy. For example, tungsten filament. So the best is to use the powder metallurgy. And certain combination of alloy or cement can be made by the powder metallurgy. And also it can control the dimension, and also it can go for automated for economical production. Okay, let's watch the video on the powder metallurgy.
Metal powders used for parts production can be a combination of various elemental particles or pre-alloyed powder. If elemental powder is used, each of the ingredients that will comprise the desired part are mixed in proper proportion into a uniform blend. With pre-alloyed powder, the proper proportion of ingredients is already present in each particle. In either case, additives such as binders and lubricants are usually added. The powder is then consolidated in molds or dies, shaping and densifying it into a compact of the desired part. At this point, the part, or compact, is in a green state, where the powder particles are just lightly joined together. In this state, the parts have a so-called green strength, which is usually only sufficient for handling purposes. The parts are then transferred to a sintering furnace. During sintering, parts are heated at a temperature below the melting point or range of the base metal, but high enough to metallurgically bond the individual particles. Sintering further densifies the parts, increasing strength. Final part density is extremely important. Although controlled porosity is required and achievable for certain parts, the performance of structural parts increases directly with increasing density.
Okay, now let's look at the limitation and disadvantage of powder metallurgy process, in which they involve with the high tooling and equipment costs, have a high capital investment for the tooling and equipment, and the metallic or the metal powder is expensive, and the problem is storing and handling metal powder because the metal powder, some type of them can degrade over the time and also fire hazard with certain metals. So you need to be very careful in storing the metal powder. And also the part geometry may pose some problem because the metal powder do not readily flow into the die during the compacting or pressing, and variation of density throughout parts may be a problem, especially for geometric with the complex shape. These are the example of the powder metallurgy product in which gear, bearings, sprocket, fastener, cutting tools, in which they can have the near net shape or the net shape without any finishing process. These are the typical parts. These are more complicated parts. And these are the bearing metal powder caps, okay, for the automotive engine. And these are the general process in which from the powder, the metal powder, they have some combination and then they have to do the mixing. So the mixing, they will add some additive like binders and lubricant, and then they will do the compacting or pressing process with the proper tooling and die. Then once they finish, they will get the green compact, then they will go through the sintering process. And let's look on the engineering powder or the metal powder, in which it depends on the size. Okay, they have a spherical, rounded, cylindrical. These are the material, okay, for the powder metallurgy, in which they can be very expensive, depends on the metal and also on the process. They have to turn the metal into the powder form. Okay, and elemental powders, they must have a high purity and also they need to be combined. Okay, for example, other metal powder to produce alloy, for example, tooth steel, and pre-alloyed powder, they have the stainless steel, certain copper alloys, and high-speed steel. So these are very convenient to produce a higher strength type of metal powder. And this is how they produce the metal powder from the base metal. Any metal can be made into powder form. It can have a different method, for example, atomization, reduction, electrolytic deposition, carbonyls, and comminution. And usually, mechanical method occasionally used, okay, to reduce the size of the powder. So this is an example. Under the SEM, you can see that they are very fine particles. And we look at the example for the atomization process, in which liquids metal steam by injecting molten metal through a small orifice. So they have a very small orifice to produce the powder. So under atomization, they have gas atomization, they have the water atomization, they have the atomization with a rotating consumable electrode, and also they have the centrifugal atomization with a spinning disc or cup. They are the different atomization process. And they have a reduction process, in which reduction of the metal oxide by removing the oxygen using gases such as hydrogen and carbon monoxide, and they turn into very fine metallic oxide, and the powder produced are spongy and porous. Usually they have the spherical and angular shape. And the other powder production process is electrolytic deposition, in which they use the aqueous solution of fused salt, and these are the purest available. And then the last one, you have the comminution, in which they use the mechanical pulverize the metal, in which they use the roll crushing, ball milling, and hammer milling. This usually for the brittle material or ductile material. And once you have all the metal turned into a powder, and then they have to go through the blending process first or mixing, in which they must do it properly so that all the powder are mixed equally to obtain a uniformity from part to part. And they have to add some lubricants to help the flow characteristic and also to reduce the friction between the metal particles. And also they have to put the binder to use to develop significant green strength and also to facilitate during sintering. So all this mixing must be carried out under controlled condition to avoid contamination or deterioration. And once they're ready for mixing, then they will go into compacting, in which they have the process to get into the shape that they wanted. So press into various shape in dies. And the purpose of compacting is to obtain the required shape, density, and particle to particle contact. And also once you finish with the compacting or pressing process, then you will get the green compact. Okay, these are the process step by step in which they have to fill up the cavity, and then they have the initial press, and once they have the position ready, then they will have the final upper and lower punching process, and then the part will eject. And then once the green compact is ready, they will go into sintering process. So this is the last process. They have to go sintering, in which is a heat treatment to bond the metallic particle to increase the strength and hardness, and usually between 70 to 90% of the metal melting point. Okay, do not exceed the melting point. Usually the sintering process, reduction of surface energy and part shrinkage will occur due to the pore size reduction during sintering. So these are the proper temperature and time for the different material. And these are the particles. When we look closely, microscopic scale, we can see that the particle initiate the contact upon the compacting or pressing. Then once they get into the sintering process, contact point grow into next when the temperature increase, and then the pores between the particle are reduced the size, and finally the grain boundary develop between particles. So you can see that these are the process in the microscopic scale. And we can see that these are the furnace for sintering. It start from here, so they have to increase the temperature in stages. So we can see here they have the preheat, and then these are the sintering temperature. Usually they have the highest temperature before the melting point, and then they have the time, proper time, and also they have to go through the cooling parts. Okay, so they have to have the proper cooling down time. Densification and sizing. Okay, sometimes secondary operation are performed to increase density, improve accuracy, and accomplish additional shape of the sinter part. Maybe they have to put holes, okay, or drill some, do some boring process. So they have sometimes secondary operation. Sometimes they have the repressing to increase the density. Once they are sintered, then they have to go for the repressing process, and then some of them have the sizing to improve the dimensional accuracy after sintering, and then they have the coining to have the detail on the surface, and machining sometimes they require, okay, such as threads, holes. Alternative to pressing and sintering, they have conventional press and sintering sequence. Usually they have the isostatic pressing and hot pressing. So we can classify the powder metallurgy parts design into 4. The first one is the simple thin shape. Okay, just press in one direction. And then class 2, they have a simple but thicker shape in which they have 2 direction. Okay. And class 3, they have 2 level of thickness. And these are the level 4 in which they have multiple thickness. Okay, they have this thickness, this one, and this one. Okay, the other one is the powder injection molding. This one, when we look, it looks like exactly the injection molding from the plastic processing. And yes, they have the barrel, okay, they have the screw, and then they will combine the ceramic powder and the binder into the extruder, and they have die and mold here for their required shape, and then they will go to the debinding and sintering process. And these are the process for powder injection. So they have the metal powder and the polymer binder. They have the mixing process, and then they have the granulation. So when they produce the granulation, then they will go into injection molding. So they have the green part here before going to sintering. Then they have to go to solvent debinding, thermal debinding, and then they have the brown part. Then they will finally go to sintering to get the finished part. So they have some additional step compared to the powder metallurgy. Okay, at the design consideration, when you want to design parts for the powder metallurgy or injection metal molding, in which they have to keep simple and uniform as possible, the shape, and need to consider for the injection of the grain compact without damaging. It's quite fragile. And then what is acceptable dimension tolerance. And then they are the sum of the parameter for the wall thickness, and step in the part can be produced if they are simple and does not exceed 50% of the overall part length. Okay. Later can be pressed during the compacting. Flanges or overhang can be produced by a step in the die. So notches and groove also can be done. And the dimensional tolerance of sintered parts are usually in order of 0.05 to 0.1 after sintering. So these are the part. Okay. So should not have the sharp radius. Avoid all the sharp radius and also all the corners. Also, they have angle, okay, for the punch allowance, not too thin, okay, for the wall. So next we're going to look at the additive manufacturing and also 3D printing.